Hello, today we're going to talk about 3D modeling with density. And this kind of gets in our science mixed in with our math, which I think is really cool. So if we look at our definition of density, I'm going to highlight that. Density is the measure of how much mass is located within a specific volume of space. And our formula for density is mass or weight divided by volume. So we want to know how much of that weight is in our volume. Volume we've been talking about quite a bit for our 3D shapes. So we're adding the mass piece on to get our density. Something very, very important is that this formula for solving for density is not given to you on the reference sheet. So you need to memorize it. So density equals mass divided by volume. And if you take a look at just an example of our two objects, we have a brick there and we have a sponge. And it says they both have the same volume, okay? The amount of space that they take up. But it says in water, the sponge will float and the brick will sink. Well, why is that? Because the density of the sponge is less than the water. Less than the density of the water. Now you may remember that from your science classes. All right, now let's take a look at example number 1. It says a block of butter weighs 200 grams. The dimensions are 8 centimeters by 5 centimeters by 6 centimeters. What is the density to the nearest thousandths? All right, so the first thing, I know that density equals mass divided by volume. I know my mass, my weight, is 200 grams. All right, I have to find my volume. So I know my volume formula is length times width times height. So that's going to equal 8 centimeters times 5 centimeters times 6 centimeters. And that equals 240 centimeters cubed. So now I can plug in my density to find. It's going to be 200 grams divided by 240 centimeters cubed. So my answer, if I plug that into my calculator, is approximately 0.833 grams per cubic centimeter. Now, we got to be careful with this. The grams per cubic centimeter, that's going to come into play for our next couple of problems. As you scroll down, you look at your reference sheet. All right, we're going to use these different conversions to come up with to help with our problems that we need to solve. In our next problem, we have, in the movie Raiders of the Lost Ark, archaeologist Indiana Jones replaces a solid golden idol with a bag of sand. The idol rested on a platform which previously counterbalanced the temple's ancient self-destructive mechanism. The idol can be modeled by a cylinder with a height of 18 centimeters and a radius of 6 centimeters. The density of gold is 19.32 grams per cubic centimeter. The density of sand is 1.6 grams per cubic centimeter. What is the mass, weight, of the idol in pounds? Well, there are a couple things I'm going to highlight that I think is going to be important in solving our problems. So the first one is that the idol is in pounds. Let me get my highlighter. It's in pounds. Okay, let's see, what else can I highlight? The idol can be modeled by a cylinder. I think that's important. The height of the cylinder is 18 centimeters, and the radius is 6 centimeters. I think that's very important because we know volume is in play. the density of the gold, sorry about that, the density of the gold is 19.32 grams per centimeter cubed. So I know I'm going to have to use some conversions here from my table because I know I have grams, I have centimeters, and all of those are going to come into play. So there are a couple of things. Let's start with, what are we looking for? We're looking to find out the mass or the weight of the idol in pounds. Okay, so we are given, in our problem, we're given grams. So we're going to have to get those grams somehow to kilograms, and then I can use my kilograms to pounds, because that's my conversion. 1 kilogram is 2.2 pounds. But even before that, let's talk about the density. Density equals my formula, mass divided by volume. So I need to find out what my volume is. We said it's a cylinder. So it's a cylinder, and I know that the formula for volume of a cylinder is pi r squared times the height. I'm given that the height of the cylinder is 18 centimeters. And I'm given that the radius is 6 centimeters. So I'm going to plug in. I'm going to have pi times 6 squared times 18. Now I can plug this all in my calculator. 6 squared, 36 times 18, and I'm going to get 648 pi centimeters cubed. Okay, now I can start plugging into my density formula. I'm given that the density of the statue is 119, here it is, the density of the gold statue is 19.32 grams per cubic centimeter. So that's going to be substituted in for my D. So I'm going to have 19.32, and that's grams, and that's per 1 cubic centimeter. That's going to equal mass. I'm looking for my mass, so I'm going to put M in terms of G, that's grams, divided by my volume. Well, I just found it, so I'm going to substitute that in. So I'm going to get 648 pi centimeters cubed. I'm going to cross multiply, and my mass equals 648 times 19.32. So that's 648 pi, let's not forget that, times 19.32 grams. And what I want to do is I want to multiply that, and I want to leave my answer in terms of pi. And my mass is going to be, I'm getting down towards the end of the page. Let's go up top. The mass is going to equal 12,519.36 pi grams. That's the mass. Now, what I want to do, I want to move that to kilograms. And you should remember that when you're moving grams to kilograms, what you're doing is you're dividing by 1,000. So all I have to do is move the decimal place 3 places, and I'm going to get 12, because it's dividing, it's going to be less. It's 12 point, whoa, where'd that go? 12.51936 pi kilograms. All right, now, what I want to do, or what I have to do, because V1 to be in pounds. I go to my reference sheet, and I know with my reference sheet that 1 kilogram is 2.2 pounds. So I'm going to multiply that. So I'm going to multiply 12.51936 pi times 2.2, and that equals 87 pounds. That's my answer. All right, let's go to B. If I can get to B. All right, we made it. So, what was needed? I'm sorry, what was the needed volume of sand to avoid tripping the self-destruction mechanism in centimeters squared? Well, let's first write down density equals mass times volume. So now we're looking for V. Okay, we know the density. The density is given to us, all right, of the gold. It's here. Okay, so it is, sorry, for the sand, it is here. Let's highlight that in green. 1.6 grams. 1.6 grams. 1.6 grams per centimeter cube. So we have our 1.6. So the density, I'm going to write this over here. Density equals 1.6 grams centimeters cubed. All right, we know the mass because we found it. Well, the mass is 12,519.36 pi grams. Okay, grams to grams, very important. We found it, we're good. We got to find the volume. So let's substitute in. So I'm going to have 1.6, and that's grams per centimeters cubed. That's going to equal, I have 12,000 for my mass, 519.36, and that's pi grams, and that's divided by V. Okay, so I'm going to cross multiply V or X. I'm going to cross multiply, and I'm going to get 1.6. Let's call it, let's go V. V equals 12,519.36 pi. I'm going to divide both sides by 1.6 because I'm looking for V. And my answer is V equals 24,582 centimeters cubed. All right, now my suggestion to you is that you go back over this video, you pause, you go through, get a really good understanding. Once you do that, write down some key ideas, and please check your understanding. We'll go over it in class, and any questions you might have, please write down questions that you might have. Class time is a good time to answer those, and we'll go forward from there. Remember, go Cats, go Knights.